The most complex and probably most important thing to understand about the CosmWasm framework is the storage offerings. And the current storage offerings aren't actually the original storage offerings. CosmWasm storage, the old package, gave us buckets and singletons where we could store things, but they weren't as easy to work with as the current abstractions. So that is now an unmaintained package. You'll see old contracts still using it, still using buckets and singletons, but even the repository's authors recommend not to use it anymore. Instead, use CW Storage Plus. We'll be using CW Storage Plus, which offers abstractions over this old massive monolithic like hash map state storage model to allow you to have better storage structures and iterate through storage in ways you can't even do in Ethereum smart contracts. These storage structures give us lots of cool capabilities, but there's a lot of boilerplate to get through. So we'll step through some of the boilerplate in these next few videos, and don't feel bad if you don't absolutely memorize every single thing. Even seasoned contract veterans go and copy some instance of multi-index when they're creating a new multi-index, and you'll see why in a second. Now, I started at the bottom here, but now we're here, and state storage allows persistence of information because contracts, they don't have, the variables aren't persistent, right? It's not a program that's running, and if you assign something to X, it stays assigned to X when someone else calls it later. That's not how it works because the contract spins up and spins down with every single call. You're calling the execute function. You don't have a scope outside of that. You can have constants, but you don't have a scope outside of that that holds information across calls. So if user A does something, when user B comes in, it's like a fresh start. The contract has no idea what user A did, what the results are, what's stored. Has user B been here before? None of that. So we need persistent storage, and state storage allows us to do that. CW Storage Plus, the simplest structure it gives us is the item. And this is a single key with a value. And it's a typed value. It doesn't have to be a number or a single character or something like that. It can be an entire type fit in that value. But there's a key and a value. In this case, for example, we might have a config item. This is a common case to use item because you're not going to have multiple configs. You have a config struct, a config type here. It's got to be serializable and deserializable, so it can be stored in storage and retrieved from storage and converted back into this type. And you have the owner of the contract. Again, the concept isn't a table of owners. There's just one owner for the contract. And let's say some arbitrary config setting, max tokens, any number of configuration settings that you might want to be changeable. You don't want to hard code them, or you might want to be settable per contract, instantiatable or settable on instantiation, if you will. But you don't need to have an entire table structure with just a single row. An item is just that. It's like a table with a single row. And you access the item. The item has this is at this index in the grand monolithic hash map that is contract state storage. And so when the contract looks up config in the storage, the key, it finds this type, whatever you store there. And now, right now, nothing is actually stored there. We've told it what type is stored at this item at this location in storage. And we've given that a constant representation throughout the rest of our contract, but there's no information about what values are actually stored there. So in your contract, you can do something like this. First, you declare a new instance of that type, config. Notice I'm using the type here and not the state storage variable or the state storage constant. This represents not the type, but the actual concept, the actual storage item. And this is just the type of the data that's in there. So I declare a new config with this owner admin max tokens 1000. And then I call that state storage constant I've created .save. It has a variety of methods. We'll look at the most popular right now, .save. And pass whatever the data store is. This might, in your case, be deps.storage. In fact, it likely will be. So whatever your data store is, whether you've aliased it with something like store or storage, or you literally have to take the deps storage and pass it in. And this has to be mutable deps. So this has to be from a deps mute which has mutable storage, or in some other way has to be immutable storage, not immutable storage, has to be a mutable storage. And then you pass a reference to the data that you want in that storage. So the data will actually be preserved in storage. The values will be preserved there between contract runs. They'll be preserved there until deleted or replaced, or somehow otherwise until the end of the network, right? Until they're somehow wiped. But the data will stay there no matter how long you need it there. Learn is brought to you completely free because of our great sponsors. Neutron, enabling developers to build breakthrough applications and onboard users from anywhere. Osmosis, the premier decentralized crypto exchange. And Obi, the smart new standard for asset management. If you want to become a smart contract developer through this lesson and others like it, head to heretolearn.xyz for uninterrupted course videos, coding exercises, and feedback directly from experts in the industry. You can then load it, and in this case, I just load it into a variable called loaded, which again is this config type up here. So we have loaded.owner and loaded.max tokens. And then you call load on that same config storage constant .load. You pass in the storage, which again, in your context will probably be deps.storage. And in this case, it doesn't need to be a mutable deps. It can be a non-mutable deps because you're just loading it and reading it. You're not necessarily doing anything to it. You're not necessarily changing it at all. You'll notice that these both have this result unwrapper. So there might be a problem where that storage cannot be used somehow. So you do get a result back and you have to unwrap it in order to, well, in this case, you're doing the safe unwrap to make sure that if there is an error, it kicks it up the chain and the contract error handler will handle it. And the same in this case. Now notice if there is an error, let's say a config hasn't been saved, then you will throw here, or well, not throw, but you will get an error that is handled by however you're handling errors. There is also a may load option in a lot of these, in these storage concepts, which gives you an option back. So you can get a none back if there's nothing at that particular address, or you can get the value back that you want in a sum. Here's update as a final example. Again, this will probably be deps.storage for you, but it's aliased here. Update, you take the store, and in items case, there's just one item, right? You're not specifying which item. So you pass it the storage, and we know that we're working on this single item in state. And what are we doing to it? We're passing in a mutable, the item mutably here, config, and then we're doing something to it. It's mutable because we're actually updating it. So your store does have to be a deps mute storage. And we're taking the max tokens, and in this case, multiplying them by 2. So if they're 1,000, then there'll be 2,000. And this update is pushed. And once again, if we have an error, we're going to handle it. Otherwise, we're confident that this went through and config was updated. Now, there are other methods as well, but save, load, and update are by far the most used, at least in my contract writing. You can find also may load, which I mentioned. So this is an easy way to store something. I say it's an easy way. It might seem rather complex. You're declaring the type of whatever you want to store, which can be whatever type you want, as long as it is serializable and deserializable. You are creating a constant that defines the storage item and where it can be found in contract state storage in general. And then you're saving a value that follows that type that you set to your contract storage. And then you can work with it from there. If you want a little bit of practice with items, and I would recommend it as these are a bunch of new concepts, try the treasure trap exercise where you'll be working with just items, not more advanced storage yet. And of course, you should be doing that over at heretolearn.xyz/storage, where you can find also the CosmWasm learning book, interactive quizzes, and exercises on a lot of topics as you work toward being a smart contract engineer in the world of CosmWasm.